How the tornadoes comes. I am trying to discuss all aspects about tornadoes. As you stand at your window, looking out at a sky filled with dark clouds that are pouring down sheets of rain and hail, suddenly it happens. A twisting column of gray descends from the cloud. At first, it's just hanging there, suspended above the land. But it soon reaches down and makes contact with the ground. At the same time, it turns even darker as it picks up dirt and debris. If you're lucky, you make it to a shelter before you can witness the immense swirling winds pulling up animals, cars, and buildings in its wake. This harsh reality can occur anywhere in the world. However, by a wide margin, most tornadoes happen in the United States, more than if you combine the yearly average number of tornadoes in every country in the rest of the world. The U.S. is also the only country to regularly experience tornadoes that reach the highest classification of violent, which cause the highest percentage of deaths. Each year in the United States, there are over 1,000 reported tornadoes. And on average, these result in around 80 casualties. But some years, it's much worse, like in 2011. The 2011 super outbreak was the largest, costliest, and one of the deadliest tornado outbreaks ever recorded, taking place in the southern, midwestern, and northeastern United States from April 25th to 28th. It resulted in roughly $12 billion in damages and left an estimated 321 people dead. Tornado deaths are caused when an individual is picked up by the strong winds or when they are struck by a large chunk of flying debris. While the death rate is significantly lower than it was in the early 1900s, the seemingly random and spontaneous nature of tornadoes makes them one of the most difficult weather phenomena to predict. Current forecasts of incoming tornadoes only provide an average of an 8.4-minute lead time. And in a scenario where not only your possessions are at stake, but the lives of you and your family, every second counts. How and why do some tornadoes become so destructive, and just how big can they get? And how might we one day be able to predict them better? For such a well-known phenomenon, we know surprisingly little about how tornadoes actually form. And understanding how they form is crucial for developing better tornado prediction models. Some scientists risk their own lives by getting up close and personal with these violent storms, all in an effort to determine exactly what's happening in and around the tornado. Most tornadoes begin with a supercell, a storm with a persistent rotating updraft at its core. Supercells form due to a particular combination of winds when wind speed and direction are different at different altitudes. This is called wind shear. When wind at ground level is blowing in one direction, and wind higher in the atmosphere is blowing in another direction, it can cause a horizontal tube of air to form. Then, as warm, humid air rises and cool air falls, the horizontal tube of rotating air can be pushed to become a vertical one, called a vortex or a mesocyclone, which can have a diameter of 5 to 20 kilometers. At this point, the whole storm starts rotating, and the supercell is born. This type of storm is the parent of most tornadoes. Near the ground, the mesocyclone can be narrowed by the strong updraft. This process, called vortex stretching, speeds up the circulation. This creates a funnel cloud. Then, the downdraft brings the rotation down to the ground, and a tornado is born. Low-pressure systems in the U.S. pull warm, moist air from the Gulf of Mexico and cool, dry air aloft from the Rocky Mountains or the high desert in the southwest, creating consistent wind shear. The states that fall in between those two regions end up being in the ideal location for severe tornadoes to form. But this is all a bit of an approximation. Exactly what the right conditions are for tornadoes to form is still a bit of a mystery. In an effort to answer the many questions remaining about tornado formation, the NOAA National Severe Storms Laboratory launched a research project in 1995 called the Verification of the Origins of Rotation in Tornadoes Experiment, or more simply, VORTEX. There were several iterations, the largest of which, Vortex 2, took place in 2009. It included over 100 scientists who used cutting-edge equipment to analyze weather measurements taken around supercell thunderstorms across 10,000 miles of the southern and central U.S., an area dubbed Tornado Alley. Over the span of 1 month, they collected data from 11 supercell storms, including one supercell tornado. The results from this project indicated that tornado formation is related to the temperature differences at the edges of the spinning air. But that may not always be the case. Mathematical models and real-life observations have demonstrated that tornadoes can arise with very little temperature difference. Clearly, there's a lot more to uncover about what exactly makes a tornado form. How they dissipate is not much clearer. Scientists are still debating the details, but generally, a tornado stops when it loses its source of instability, like heat or moisture, or its vorticity. One way this could happen is by encountering a cold flow of wind from a rainstorm, called an outflow. But of course, it's what happens between its formation and dissipation that's really important. How much damage did it cause? How many lives did it take? Just how destructive was it? This is what a tornado's rating is based on. After the tornado has ended, experts examine and tally up the damage. They look at what type of buildings were affected and how badly they suffered. They then use the enhanced Fujita scale to assign a rating from 0 to 5. This assessment is also used to estimate wind speeds, varying from 100 to over 320 kilometers per hour. And assessing the damage is often the only way scientists can estimate how strong a tornado was, since it is rare that they are able to take a direct wind speed measurement. And sometimes the damage is absolutely catastrophic. Out of those that have had their wind speed directly measured, the tornado with the highest wind speeds began in Bridge Creek, Oklahoma on May 3, 1999, during a massive tornado outbreak involving over 70 tornadoes. This particular EF4/EF5 tornado traveled across heavily populated areas in Oklahoma, and with wind speeds topping 512 kilometers per hour, it completely obliterated over 200 homes over the course of 1.5 hours, killing 36 people. It was classified as an EF5 because the EF5 category has no upper limit. But its wind speeds were so fast, some scientists think it should have fallen into its own new category, an EF6. The problem with creating an EF6 category is that the vast majority of structures are simply gone at the EF5 rating. And besides the rare tornado like the Bridge Creekmore tornado that has its wind speed directly measured, the rating comes from the destruction it leaves behind. And complete and total obliteration looks the same if the wind was 350 kilometers per hour or 550 kilometers per hour. Scientists believe theoretically the fastest tornado possible on Earth would be 611 kilometers per hour. The Bridge Creekmore tornado was not far off. There's even a web browser extension that can show you the breakdown of how news outlets from across the political spectrum are reporting on the same story. This helps you immediately notice certain biased trends, which is helpful, but also fascinating. Subscribe my YouTube channel. And thank you for watching.